we're going to spend today talking about how addition interacts with multiplication and how multiplication interacts with exponents. So we're going to follow along on the first page of this worksheet. So it says, draw a picture of 3 plus 3 plus 3. So I'm just going to do this. 3 plus 3 plus 3. Can I change 3 plus 3 plus 3 into something a little more simple? No, not 3 to the third. That certainly wouldn't work. 3 times 3. 3 times 3 times 3. So here we have a rectangle with 3 rows and 3 columns. Okay? If I wanted to do 3 times 4, what would that look like? Well, I could have 3 rows of 4 dots, and at the same time I actually have 4 rows of 3 dots. Right? Okay, if I move over here, 4 times 5, 4 rows of 5 dots or 5 rows of 4 dots. Okay? So if I were to take this number 9 or this number 12 or this number 20 and multiply it by a fraction, for instance, and you don't need to write this down, just kind of watch. 9 times 2/3. What is 9 times 2/3? 6. 2/3 of 9 is 6. How does that relate to the picture? So I have 3 columns. I have 3 columns. How many of those columns am I keeping? 2 of the 3 columns. I'm keeping 2/3 of the dots, which is 6. So if I went over here and I times 12 by 2/3, how would you do that? We need to go into rows, right? So there are 3 rows, and I'm keeping 2 of the rows. So basically what I'm saying is, what is 1/3 of 12? Can 12 be split into thirds? Yes, if I split 12 into thirds, what do I get? 4. And how many of those 4s am I going to keep? 2. So 2/3 of 12 is going to be 8. Now here's something that's a little tricky. What if I did 5/4 times 12? Can I split 12 into fourths? What is it? 3. So if I look at the columns, a fourth of 12 would be 3. How many of those 3s do I need? 5, but I don't have 5. So I'm going to add another 3. So I'm going to keep 1, 2, 3, 4, and I'd do another one, 5/4. So what is 5/4 of 12? 15. Okay? So that's how you put that together using, oh, well, better late than never. We're going to do the same thing now with multiplication. And we're going to come up with the fractions of multiplication. So 2 times 2. I'm going to take 2 dots and double it, which gives me 4 dots. Okay? Over here, I'm going to take 2 dots and do what to it? Not triple it. Double it and double it again. Okay? So if I take 2 dots and double it, and now I'm going to change directions because it will kind of help us see, keep this together. I'm going to double it over here. So, do you see 2 times 2 in this picture? Started with 2, doubled it. Do you see 2 times 2 times 2 in this picture? How? So I started with 2, doubled it down, and doubled it across. So my original 2 doubled, then doubled. Okay, what would this one look like? Start with 2, double it down, double it across, and then double it down. So let me show you. So that's my original 2. I'm looking for 2 times 2 times 2 times 2. So my original 2. Here is my second 2. Maybe. Here is my third 2. And here is my fourth 2. So I have 2 times 2 times 2 times 2. Everybody get that? Okay. Now I'm getting kind of lazy, so I'm not gonna draw all of these out. But if I start with 3 dots, what am I gonna do to those 3 dots? Triple it. So that would be 3 squared. What would 3 to the third look like? So I would take this picture with 9 dots, and I would triple it, which gives me this, for a total of 27, right? So for letter I, what is my picture going to look like? It's going to have 81, which is 3 of those. So I'm just going to kind of build this, and each one of those has 9 in it. Okay? So if I have a series of common additions, I can turn those additions into multiplications. That's like rows and columns. If I have a series of like multiplications, I turn them into exponents. And it's like double, then I double, 2, then I double, then I double, then I double, or 3, and I triple, and I triple, and I triple. Okay? So down here at J, 2 to the third is 8 dots, and we decided it looked like this. Make that a little bit bigger. So 8 dots. Well, if 2 to the third equals 8 to the first, what would 8 to the 2/3 be? This is something that you've never seen before. So 2 to the third is 8, and we want 2/3 of 8. So this is saying we need to break 8 into 3 groups. Can you do that? Oh, good. Now, this is not multiplication. It's not multiplication and addition. It's an exponent. So, back on the first problem, when I had this, and I wanted 2/3 of 12, remember that I built this by adding columns. 1 column, 2 column, 3 column, 4 columns, which also had 3 rows, and 2 of the 3 rows ended up being 2/3 of 12, which was 8. Okay? But now we've moved on to multiplication. Can we split 8 into 3 multiplications? Well, we already did. My original 2, my first double, and my second double. So can 8 be split into 3 multiplications? Yes. 2 times 2 times 2. How many of those 2's am I going to keep? 2 of them. So if I keep this and throw that out, my answer is, try again, 4. Now, Somebody over here said, in regard to breaking 8 into 3 equal pieces, how do you do that? The cubed root, right? So what's really happening here is the cubed root of 8 squared. What is the cubed root of 8? 2, and 2 squared is 4. So the cubed, so 8 to the 2/3 is really the cubed root of 8 squared. Or you could actually do it this way too. You can square 8 and then take the cubed root, which is kind of interesting. The cubed root of 8 is 2, and 2 squared is 4. 8 squared is 64. What is the cubed root of 64? What times itself is 64? 4. So it works both ways. Whether this squared is on the inside or the squared is on the outside, you get 4 in either case. All right, next problem. So we decided that 3 to the third was 3 dots and then 3 of those. So this is 3 times 3 times 3. Can 27 be broken into 3 equal multiplications? Yes. What happens when we keep 4 of those multiplications? We put another 3 out there. 3 times 3 times 3 times 3 is 81. Using square roots, we could do the third root of 27. What is the third root of 27? 3. And if I raise that to the fourth, I get 81. Or I could do 27 to the fourth. 27 raised to the fourth. And then I could do math. The cubed root of the answer is 81. So it works either way. Okay, for this problem, 3 to the fourth looked like this. Had 81 dots. 3 times 3 times 3 times 3. What is 81 to the 3/4? Well, how many of those am I going to keep? 3 of them. So 3 to the third is 27. Okay? Turn the page. Okay, example 1. 400 to the 3/2. Before I start, is my answer going to be bigger or smaller than 400? Bigger, because I'm keeping more than I already have. So, can 400 be broken into 2 equal groups? What is it? Not 200. That would be dividing by 2. What do we really want to do? Square root. So wait a minute. 400 to the 1/2 is exactly the same thing as the square root of 400. Yes. That's what you've been doing for years now. So if I did 400 raised to the 0.5, I get 20. What would the cubed root of, let's say, 27, how would you write that as an exponent? 27 to the 1/3. A fifth root would be 27 to the 1/5. So you've actually been using exponents for a long time, you just didn't know it. Okay, so 400 broken into 2 equal groups is 20. How many, well, 20 times 20. How many of those 20s will be in my answer? 3 of them. So 20 to the third is going to be 400 times 20, which is 8,000. Okay. Teja, do you get this? Okay, we'll try again. So number 2, we want to break this into 3 equal multiplications. Something times itself is 1 over 1,000. So let's look at 1. What times itself is 1? 1. Do you get that? 1 over. What times itself is 1,000? 10. What if I don't know that? Just do the cubed root of 1,000. So I want to know math cubed root of 1,000, and I get 10. So if I take 1 over 10 times 1 over 10 times 1 over 10, I get 1 over 1,000. Does that make sense? How many of these 1 over 10s will be in my answer? 2 of them. So if I have 2 of these, what does that give me? 1, because 1 times 1 is 1. If I have 2 of these, what does that give me? 100. So 1 over 1,000 to the 2/3 is 1 over 100. Okay? Now the next one's kind of tricky. There are a couple different ways to think about it. But first off, what is the cubed root of 3? I don't know. 1 point something. What'd you get? 1.4, on and on. That's messy. Don't want to do it. Okay? So, one thing I can do is move this 12 inside. And I could calculate 3 to the 12th. It's going to be some huge number. And then take the 3rd root of it. But really, this is just 3 times 3 times 3 times 3. How many of these 3's am I going to keep? Why 4? You want to keep 1/3 of them. Right? So I have all of these 3's lined up, and I want to keep 1/3 of the 3's. So 3 to the 4th is 81. Now if that doesn't make sense, let's convert this to fraction form. 3 raised to the... Which number goes on top? Well, if the square root of x is x to the 1/2, so x to the 1st square rooted is x to the 1/2. So this number goes there, and this number goes here. So the 3rd root of 3 to the 12th is really 3 to the... Okay, you jumped ahead. Uh-oh, does this not make sense? Okay, so if I have x to the 4/5, that is the 5th root of x to the 4th. So this number becomes the root, and this number becomes the exponent. That's where we're headed today. So here, if I go backwards, 3rd root of 3 to the 12th, that's going to be 12 over 3. Well, what is 12 over 3? 4, and 3 to the 4th is 81. Okay? So if you understand one way, do it that way. If you understand it the other way, just convert and do it the other way. Okay, number 4. Can 81 be broken into 4 equal multiplications? Well, it can't be divided by 4. But is there something to the 4th power that equals 81? 3. So it's 3 times 3 times 3 times 3. Can 16 be broken into 4 equal multiplications? 2. 2 times 2 times 2 times 2. How many of those 4 am I going to keep? 3 out of the 4. So 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. Okay? Now, Could I just plug that into my calculator? Well, yeah. I could have done 81 over 16 raised to the 3/4, and it would have spit out the right answer. But on this first page, I want you to think through it numerically. Okay, you can go ahead and use your calculator and say, well, I need to break 81 into 4 equal pieces. So let's try 2 to the 4th. No, that didn't work. 3 to the 4th. That's it. So 3 times 3 times 3 times 3. Okay, don't just plug them in. You'll need to show some sort of work like this. Okay, on the back page, look at number 22. Can 87 be broken into 3 equal multiplications? Well, 2 to the 4th is 16. 3 to the 4th is 81. 5 to the 4th is 125. So it would be some sort of decimal between 4 and, or 3 and, or sorry, between 3 and 4. I skipped, I'm sorry. 4 to the, whatever. I'm not making any sense. So for this one, you have to plug it in your calculator. So we would take 87, and we would raise it to the 4/3. And if your calculator doesn't lift up the exponent like mine, if you see that little caret button, then you need to put parentheses around the 4/3. Whose calculator does that? The old way. Let me see it. So if your calculator looks like this, see that? Then you need to do parenthesis 4/3. So it needs to look like this. Otherwise, you're going to raise it to the 4th, and then after you're done, divide it by 3. So that's 385.5, and my calculator gives the same value. Okay? All right. Good luck.